Okay, I think it's recording, so I'm going to go ahead and start. This is a chapter on radicals, and radicals are pretty much square roots. We know them as square roots. There's other roots other than square roots. We can take a cubed root, we can take the fourth root, the fifth root. Anything that we can do as an exponent, we can also do as a root. We'll learn during this chapter that a root is actually just the opposite of an exponent. It pretty much undoes an exponent, whatever an exponent does. So I want to start out by just reviewing the real number system. We learned earlier in this year that our smallest group of numbers is the natural numbers, which is our counting numbers. They're 1, 2, 3, 4, 5, so on, all the way up to infinity. Then we can add to that, so that's 1, 2, 3, 4, and so on. The next group, you have a question?
Yes. Does natural include 0?
No. Okay. The next group is the whole numbers. Whole numbers include 0. Okay. It's all of the natural numbers plus 0. So that would be 0, and then 1, 2, 3, 4, and so on. And that's the next group. Outside of that, we have integers. What do we add when we get to integers? Say it louder.
Negatives.
Negatives. So that's where we would go to -1, -2, -3. We're still not doing fractions or decimals. Okay? And then outside of integers is where we add the fractions, we can add decimals, and it starts to get to be very large because there's an infinite number of fractions and decimals in between every single integer, and there's an infinite number of integers. So the real number system is a huge system, and it's what we use for pretty much anything that we do in math. The only requirement here is that for a number to be considered a real number, it has to be able to be written as a fraction. I'm sorry, this is the radical numbers. Rational. Figures when I'm recording, I start saying everything wrong, right? This is the rational numbers, not the real numbers. We'll talk about real numbers in just a second. Rational numbers are all of your fractions, your decimals, but they have to be decimals that either end, like 4.5 ends, or repeating decimals like this, where they actually repeat in a pattern. And it can be any pattern. It could be like a repeating pattern like this. As long as it repeats in a specific pattern, it's considered rational. And any terminating decimals, where there's nothing after the 5 here, that would be a rational value. What that is those are values that can be written as a fraction. You guys remember that?
Yes.
Okay. Outside of rational numbers, we have irrational numbers. And these are not a part of the rest of this system. Okay, irrational numbers are numbers that cannot be written as a fraction. So the only irrational numbers are numbers that decimals that go on forever without ever repeating in a pattern. Okay? The way that we get an irrational number, some irrational numbers we use like pi. Pi is an irrational number. Oops, 6, 5, 3, 5, 8, 9, 7, and it goes on and on. It never repeats. It never stops. So those are numbers that we use on a daily basis that we know. There's other ones that you'll use when you get into higher math. But the way that we can easily get an irrational number, so if I said write an irrational number on your paper other than pi, and you had to come up with something, the way that we can ensure an irrational value is by trying to take the square root of a number that does not have a perfect square root. So give me an example of a number that's not a perfect square. Carson?
3.
3. If I were trying to take the square root of 3 and put it in my calculator, anybody have their calculator out?
Yes.
Okay, put the square root of 3 in your calculator and tell me what you get.
The square root of 3 is 1.732050808.
Okay, so this will go on forever. It will never turn into a pattern, and it will never end. And I know that because the way that I got it is I tried to take the square root of a non-perfect square. And that's what gives us irrational numbers. So the 3 itself is not an irrational number. What type of a number is 3? Well, yeah, but what type of a number in this system is it?
Haley was sick this morning, so I didn't get a
Thank you very much. It's which one?
Natural.
It's natural, which means it's also
Whole.
a whole number. It's also an integer. It's also rational. Therefore, it is not irrational. You can't be a rational and an irrational number. It's not the 3 that is irrational. It's the square root of 3, which is this value here. And that's very important to remember because this whole chapter we're going to be dealing with irrational and rational values. So you have to understand that it's the value of the square root of 3 is what's irrational. Okay? But instead of writing something that's not 100% accurate because we have to put dots here or round it off because we don't know the exact value, we can write it as the square root of 3, which is an exact value. You know how we're always talking about fractions versus decimals when we deal with rational numbers, because the fractions are an exact value, whereas the decimals, sometimes you have to round it off. So to write the exact value of an irrational, we write it as a square root. Okay? That's why it fits into this chapter with radicals, because this whole chapter is about roots. So we can write irrational values as square roots. Okay? Moving on. If I were to, let's go to the next page. Okay, so let's talk a little bit about square roots and just do some review here. If I were to say, give me the 2 square roots of this number, what would you guys do?
In our calculator.
So,
Okay, you could put it in your calculator if you don't know it.
wait, what's the closest square root to 225?
225 is actually a perfect square.
Oh, it is?
Mhm.
The square root of that and then the square root of with the negative.
Yes, Lexi says we're going to take the square root of 225. We're going to write it with a positive and with a negative. Every square has 2 square roots. The principal square root is the positive, okay? And then we also have the negative square root. So, anybody get this one?
Negative 15 to 15.
15, there we go. So the 2 square roots of 225 are 15 and negative 15. And we can write that with this symbol, a plus minus symbol, that tells you one's positive and one's negative. Okay, so the 2 square roots of 225 are positive 15 and negative 15, positive 15 being the principal square root. And it's principal spelled like the person, principal. Okay? Didn't you learn that?
No.
You didn't learn to spell principal because it's
I
principal? Emma
Oh, wait,
remembers.
wait.
Because they're proud.
I knew there's
Yeah.
2 different spellings. I only know how to spell certain
Principal, like an idea,
And a
is
principle in the law.
spelled P-L-E at the end, but principal, the person, is P-A-L at the end.
things.
So he's your principal.
Principal.
Yeah, I'm not a
Yeah.
So
speller.
he's your
I'm teaching you English and math today.
I don't really pay attention to that.
Well, now you know. Principal, the person, is principal. He's your pal. He's your buddy.
He's
He's
my
your
pal.
principal.
Unless you're a trouble student, and then he's not your buddy.
He's not my
Yeah, she's gonna notice how off track. we
Okay,
are.
sorry, Eli.
What is it called when the square root is negative?
When the square root is negative, it's just the negative square root. Or the opposite of the principal square root, I guess. They don't give it a special name. Okay, it's just a negative square root. Now, when we take, in general, unless I'm asking you for both, if I just say, what is this answer, what would you tell me? 8. We learn very early in math to give the principal, okay? So what we do in this chapter to differentiate is I might say something like this. So specifically what I'm asking for is the negative square root. So what would the answer be?
Negative 10.
Negative 10. Okay? Exactly. Now, what if I did this?
You're looking for
Positive 10. Just kidding. It's
Negative or
negative.
positive?
I'm just kidding.
Negative and
It can't work.
It's not.
Carson, why can't it work?
Because a negative times a negative is a positive.
Absolutely.
So,
Because the idea of a square root is we're asking what times itself equals this number. nothing times itself will ever equal negative 100. Because negative 10 times negative 10 is positive 100, and positive 10 times positive 10 is positive 100. And if we do negative 10 times positive 10, then we're not multiplying something by itself. So negative numbers have no square root. Okay, this is where we would actually get into non-real numbers. Okay, is when we start to take negative square roots, then we have imaginary numbers, which is not a concept we learn in algebra. It's a concept for, I think it's pre-calculus and calculus when you first get into imaginary numbers.
Why is there
So,
imaginary? What?
for the purposes of 8th grade algebra, if you have the square root of a negative, either you've made a mistake or there's no solution, or when we get into quadratics, that'll have another meaning to it, which we'll talk about. Okay? But for right now, if we're just asking for square roots, that would be a no solution. Please note the difference between these two. Okay, it's really important. All right, that was all review. So let's start talking a little bit about, well, we'll go from there. This will move us into real values. If I were to take the square root of x, okay, now I'm not talking about rational, irrational, but talking about real numbers versus imaginary numbers. So remember, irrational, rational, if x is a perfect square, then it's a rational number. If x is not a perfect square, then it's an irrational number. But now I want to talk about the idea of what would make this a real value and what would make it imaginary. What are some values of x that would give me a real number if I took the square root of it? 4. That's true. That would be real and rational. Okay.
8.
16. Now 8. Does 8 have a square root?
Oh, I meant you. I meant
No,
you
no, no,
what it,
it's
what
okay.
it was of, like what you get. Like, the
Oh,
result.
yeah.
I thought it was the result.
But let's talk about 8. If I put 8 in here, what kind of a number would I get?
You get irrational.
I would get an irrational. Is that real or imaginary?
It's real.
It's real. So that would be real, but irrational. Okay, that would be if x equaled 8 and I tried to take its square root. The square root of 8 is real and irrational because it's a positive number, but it's not a perfect square. Okay, what's another real irrational that I could get?
7.
7, absolutely. Okay, now let's talk about not real or imaginary. What values would I put in for x that would give, if I took the square root, would give me a result that is not real?
-4.
A improper fraction.
An improper fraction.
No.
No, I could take that. An improper fraction would give me a real, because something like this is, or that's a mixed number.
Yeah, what about mixed
Okay.
numbers?
It doesn't. You can still.
Are they in the irrational category?
It depends on this value. If it's a perfect square, then
Oh.
it's rational. If it's not a perfect square, then the square root would be irrational. So like 4 5/3 is not a perfect square, so it would be real but irrational.
That's right.
But I think if I were to do like 16 over 49, that would actually give me, that's a perfect square.
Right.
Because if the numerator and the denominator are perfect squares, then the square root is going to come out perfect. Okay?
What is not real? Yeah, where
Refer
is
back
not
to
real?
this.
What's the not real there for?
A negative.
Not real.
Okay. What? -16, absolutely.
It's not real.
If I put in a -16 here
You're not
and try to take its square root, I'd get an error. You can't. It's not a real number. The square root of a negative is not a real number. So what are some other values of x?
-4.
-4,
So negative.
-8,
Yeah, pretty much.
-5.77. Oh, need the negative sign. Any negative value,
Main error.
absolutely. If you try and take the square root of any negative value, you're going to get a not real result.
What about 0?
0 has a square root. The square root of 0 is 0. So that's both real and rational. Because 0 times 0 is 0.
Yes.
Okay.
That's true.
So if it's just x, then pretty much the values that would give me real solutions or real values, what could I put in for x? What can we talk about this as a range, like as a set of numbers? What set of numbers would give me a real answer? Lexi?
Any real number greater than 0. Or
Anything?
0 or greater.
Good. Any value of x that is greater than or equal to 0. That is the set that would give me a real number answer for this particular expression. Does everyone understand that?
Understood.
Okay. Ready to make it a little bit more complicated?
Let's do it.
Okay, let's do it.
What was it? A set that will what?
Give me a real number answer to that expression.
Thank you.
Or if I were to simplify that expression, I would get a real number. Okay, so let's kick this up a notch.
That sounds fun.
Always.
Emerald Lagasse. You guys don't watch Food Network? Kick it up a notch?
I do not.
You're too young.
It makes me hungry and I know I'm wrong.
It makes you hungry. That's the
Everything
point.
that you talk about, we're always too young or like it's inappropriate.
Dude,
Yeah.
that's for-
You're like, that's a great
Sorry.
Oh, it's not. It's
That's a
totally
great movie.
appropriate
Don't
for
watch
us
it though. You're too young.
15-year-olds.
So let's look at this expression. Y minus 8. Okay. Now, if I were to take the square root of y minus 8, I want to know what values of y, what is the set of values that I could put in for y, that when I evaluate this expression, I'm going to get a real answer. Lexi, what do you think?
8 or greater.
8 or greater.
That should be the same.
Okay, well, let's test a couple. Lexi's going out and saying, let's say anything equal to or greater than 8. So let's test 9.
9 minus 8. It's 1. That's square root of 1.
What's the answer?
1.
Is that a real number?
1. Yes.
Yes.
Absolutely. Okay. Let's try y equals 12. Or no, let's try something that's going to give us irrational. 13. Okay. 13 minus 8 is
2, 3, 4, 5, 6.
5. Is that going to give me a real answer?
That's going to give you a non-real answer. A real answer.
It's going to be real, but
But it's going to be irrational.
irrational. Good. Real but irrational. But it's still real, so that's true. Okay. So far her theory is good. Let's try something that does not is not included in here. What's a number less than 8?
7.
7. Okay. So if I put in a 7 for my y,
Oh, it won't be real because it's
-1.
Okay. square root of -1,
There's no negative
No
1, so
solution.
no solution.
It's no
solution.
It's
Okay. That's your
Lexi,
you were right.
No, it's like this thing because you talked about before, and it's something like 4i.
yeah. The square root of -1 is a value called I that you'll use in calculus.
Oh,
Yep. That's the basis of imaginary numbers is the square root of -1. I'm surprised you remembered that. That's awesome,
I
Lexi.
wrote it down.
Good deal.
I was on 2.
I thought it sounded
All right. So do you think she's right?
I think she's right.
I agree. I absolutely think she's right. Okay. All right. Let's look at another one. Square root of n squared
Plus.
plus
1.
3. Okay. Think about it.
I'm thinking.
So
you could do
something
like,
squared plus 3.
Something squared, some value squared.
so you do like.
So we're
three.
looking for
Squared.
the set of values
no.
that we could put in for n that would give us a real number if we were to evaluate this expression.
It's -1 or greater.
Okay, -1 or greater?
Yeah.
What do you guys think?
Oh.
Sure.
So it's 0 plus 3
Look
is
at it.
3, so.
Okay, let's try it. She thinks it is
-1 or greater.
greater than or equal to -1. So let's try -1. What's -1 squared?
Negative. No, 1.
1 plus 3 is 4.
Oh,
So
no, no, no.
Square root of
4
4
is
is 2. Okay, so
2.
-1 works. What about 5?
5.
5
Um,
squared,
25 plus 3, which is
28. Does that give me a real answer?
Yes.
Square root of 28?
Yes.
It's real, but
Irrational.
irrational. So that one's fine. Okay, now let's try an anti-example, okay? What's something less than -1?
Negative.
-2.
-2. -2 squared?
Is
Positive
negative
4.
+4 plus 7. What's the
Which
square?
is
Plus 3.
Oh, what happened?
It's prime.
It
became
can
a
still
negative.
work.
That one worked too. So this is not going to work.
So
Get that out of there.
n can be any like real number or rational number.
Real.
Real.
Lexa says it can be any real number.
Well,
Because
what would
these,
we
Can
do
anybody
with
prove her wrong?
There's a negative about 10.
because
I forgot.
something times this negative is a positive.
I
and
forgot
that's
What
the
is-
reason
say it again, Carson?
Something times this negative is a positive. Or something
A
times a
neg-
negative. Sorry, not it.
I think
a
it's
negative.
true
A
because
negative times a
And then
negative
so
equals a
something
positive, so
squared.
every
A
time-
negative times a negative equals
Sorry,
a
that's
positive.
what I meant. I'm sorry. That's
Something
what-
squared.
Yes. Something.
Okay.
I was trying to say
Something squared is always positive.
Yes.
So no matter what we put in for n, any real number squared will give me a positive. And if I add 3 more, that'll give me more positive.
Yeah.
So there is nothing we can put in for n that would make this underneath the radical sign negative.
So it would be no solution.
How would
It
we-
equals any.
No, it would be
No.
all solutions.
All solutions, all real numbers. The question is, what can we put in for n that makes this real? Well, what we're saying is there's nothing we can put in that wouldn't make it real because nothing makes n squared plus 3 negative.
So anything
So-
that's
so-
squared-
Our answer is n is the set, so it would be n such that n is a real number. That's all.
Squares are always all.
Alrighty.
Squares are always positive, okay? N such that n is a real number. There's your set builder notation, okay? Or the set of all real numbers.
But that doesn't work with every
Oh, yeah, we're
exponent
coming back to
because if
that.
it's cubed, then it must
True.
be
Emma's
So what
raising
is
a
this
very
rule
good
for?
point. She said that doesn't work with every exponent because, like, x cubed could give us positives or negatives depending on what we put in. But x to the 4th will always be positives. So for even exponents, 2 exponents of 4, 6, 8, 10, you will always get a positive result. All right?
What is this for? What is this equation thing for?
This is, we're trying to find what will give us a real answer out of a radical expression. What values, what we're looking for is called the domain values. What is our domain? What values can we put in for the variable that will give us a real answer in this expression? So we're actually trying to define the domain of these expressions. Okay. Now, let me caution you with that theory, though.
Caution.
Watch
Wait,
this
so
one.
all the even exponents are going to be positive, and all the odd exponents are going to be
X,
negative.
no. Anything to an even exponent will result in a positive number. Anything to an odd exponent will result in a positive if it is a positive and a negative if it's a negative. So that's what you have to keep in mind when you're thinking about this, okay? But look at this one. I'm not adding, am I?
No. So
You subtract
Okay,
it
these
would,
Eli?
be, it would be anything greater than 16.
Well, x squared needs to be 16 or greater.
Yeah, that's what I was saying.
So,
So
4 or greater.
okay, positive 4 and up will give us 16. So positive 4, positive 4.1, all the way up to positive infinity, right? Hold on, let's let someone else try. I'm sorry, let me move this so you can see it. Okay, so that's true. Anything positive 4 or greater, if we square it and subtract 16, we'll still have a 0 or more. But is there anything else that would work? Eli?
negative 4.
Negative 4 would work because negative 4 squared is 16.
Oh, it's
16 minus
it's
16 is
four.
0. What else?
Anything less than negative 4.
Good. Good job, Eli. Anything less than negative 4. Think about this. What's negative 5 squared?
Negative 5 squared
That
is
would be
25.
25.
Yeah. 25 minus 16 is a positive, right?
Well,
So-
you could also make like a line graph on this, like anything.
So we don't-
less
Yeah,
than
you could
negative
because this is
4.
just like 2 chapters ago when we were doing our sets and we were putting our sets on line graphs,
Yeah.
like our conjunctions and disjunctions and sets and unions and intersections. Absolutely. So let's look at this. Anything greater than or equal to positive 4 and anything less than or equal to negative 4. So if we think about our line graph, right? Here's my 0. We're talking about
Negative 4, positive 4.
this way and this way. Right? So how would I write that?
In set builder notation. How would you rate
Okay.
it?
anything greater than 4 or less than -4.
Well, we would write, the way that we would write this end of it is
And
x is less than or equal to -4,
Or
Oh,
X is
and
greater
Or,
than
there you go,
equal to-
Emma.
Yay.
or x is greater than or equal to +4.
Yeah.
And that would be your answer. That's your domain for this particular expression. For this expression right here, okay, the domain of this expression, or the values of x that would give us a real number if we were to evaluate this expression, it's anything less than or equal to -4 or anything greater than or equal to +4. Make sense?
Yes, ma'am.
Okay, so that's the basis of sections 11.1 and 11.2.
Oh, we did
Okay.
both.
So I'm going to stop the video there.